In this video, I'm going to talk about scientific notation because this is something we use quite frequently in chemistry. Now, scientific notation is just a different way of writing numbers, and we typically use it for very, very small numbers or very large numbers because it eliminates the need to write a lot of zeros on either side of the decimal point. And so the way it's written is that we write it as n times 10 to the n. So here is our value, and then times 10 to the n, and this little n tells us which way we move the decimal point to expand that number in scientific notation. And so here's a couple of examples of numbers that were written out. Here we have this very large number, and we rewrite it in scientific notation, and we rewrite it this way. And so this 8 represents the number of decimal places that we moved over to get to have only one digit to the left of the decimal point. Now, notice that when we start writing a lot of zeros, whether you're looking at it on your calculator or writing it on a piece of paper or punching it in, it's very easy to miss something. And when we change the number of zeros, we change the value of that number. So if we enter things in scientific notation, it's very clear what the value of that number is. So for very small numbers, we can do the same thing. Again, what we're looking at is we're looking at the number of places we're moving the decimal point. And so we can see 2, 3, 4, 5, and 6. And that shows us the same thing that we see over here times 10 to the minus 6. So when we have a positive exponent, we get a very large number. When we have a negative exponent, that means we have a small number. And when we say we have a small number, we mean something less than 1, so that there's actually um, several zeros before or after the decimal point before we get to an actual non-zero digit here. So when we look at scientific notation, we see that we can move the decimal places, but why can we do that? How does that work? And so what I want to look at is, I'm going to look at an example here of 2,400 meters. Now, I can rewrite that as 2.4 times 1,000. Those two values are equivalent to one another. I can then take my 1,000 and expand that to 10 times 10 times 10 because 10 times 10 times 10 equals 1,000. And so then what I get to is 2.4 times 10 to the third. So it's telling me I can take 10 times 10 times 10. Much like if I see 4 squared, what that means is 4 times 4. So 10 to the third means 10 times 10 times 10. So when I look at this in comparison to what we looked at on the previous slide with counting decimal places, we see the exact same thing. If I'm here and I move my decimal place 1, 2, 3 spots, I end up with 2.4, and I'm going to move it 3 decimal places over. So my exponent is positive here because I have a number that is greater than 1. When I look at a number less than 1, I'm going to move my decimal places in the opposite direction, 1, 2, 3, 4. But what I also see is that instead of looking at multiplying by 1,000 or by tens, I'm actually dividing to get an equivalent value. So I have 8.6 divided by 10,000. Again, I can break that 10,000 up into 10 times 10 times 10 times 10. And I have 8.6 divided by those four tens. And then I can rewrite that as 8.6 times 10 to the minus fourth. Okay, so that negative value here, that negative exponent, tells me I'm dealing with a number less than 1. And so it also tells me that I'm moving my decimal point to the right so that I can get 4 decimal places over. I end up with 1 digit to the left of the decimal place here, and that's true in all of our scientific notation. We only want 1 digit to the left. All other non-zero digits should be to the right. So here we have an example on a calculator, and the way you enter this on your calculator is a little bit different than typing times 10 to the. And the reason we want to enter it differently is because we want to make sure that the calculator treats this as a single number. And so this becomes really important when we start looking at calculations. And so every calculator works a little bit differently. I'm giving some examples that I've seen on the most common calculators, but you need to check and make sure that you are getting it correct. So that way when you're on an exam, you know you're entering the number correctly. So if I were to type in 4 times 10 to the power of 6, the calculator actually sees that as two numbers. It sees that as a 4 and as 10 to the 6. Now if we're doing multiplication, it's not a big deal, but when we start doing multiple calculations with numbers in scientific notation, we have to start worrying about the order of operation. So any division or a combination of addition and multiplication, then things start getting a little bit more complicated. So you always want to enter numbers that are in scientific notation the correct way into your calculator. So most calculators have a button labeled EE. On some calculators, I've also seen it that it's listed as EXP. So that means exponent. Those mean the same thing. What we're looking at here is that we want to have some way of entering this so that the calculator treats this as a single value. It's not treating it as a 4 and a 10 to the 6. It's looking at that number as 4 times 10 to the 6. And so you can enter 4, the EE or the exponent button, 6, and what you'll typically see on your calculator is a couple different things. Some will show 4 with a space, and over on the far right you'll see 06. Some you'll see 4 with a little 06 on the right. Sometimes you'll see 4e to the 6. Any of these things are acceptable. It just depends on what your calculator model actually does. Likewise, when we're dealing with a small number, so a number less than 1, when we're entering it in scientific notation, we typically enter our number, then our EE or our exponent button, and then we have to choose the plus or minus option and then our actual exponent. So that's going to give it the negative. You don't want to use the minus sign because the calculator sees that a little differently. Make sure you look for the negative sign. Again, the way it looks on your calculator may vary, but make sure you figure out where those buttons are and always use the calculator you're going to use on an exam when you're practicing problems or in class so that you're comfortable using it and know where all the features are. Again, you're going to see a variety of displays depending on the calculator model.